So question number 61. Equal area criteria is used to determine. So four options are given: steady state stability, transient stability, reactive power limit, and the rating of circuit breaker. So we know that whenever we want to determine whether the system is transiently stable or not, then we need to use equal area criteria. So correct answer for this particular question, it will be the transient stability. So in case of equal area criteria, so basically we are considering the power angle characteristic. It is a graph of delta versus the electrical power output. So its characteristic will be something like this. So for a given mechanical input, so this is the mechanical input PM. So we consider if there is a change in the mechanical input, if we increase the mechanical power input or decreased, then in those cases whether our system is stable or not, or in case of a parallel line, if fault take place and if the circuit breaker do not open in a given time, then system may become unstable. So all these sudden changes are there. So change in the mechanical input, occurrence of fault or disconnection of any parallel line. So such events, during such events, if system is stable or not, so that can be judged by using equal area criteria. So two areas will be formed depending on the case: the accelerating area A1 and decelerating area A2. And in order to have a system stable, A2 should be greater than or equal to A1. Now this steady state stability we can judge from power angle characteristic. The reactive power limit we can determine by using the power circle diagram. The rating of circuit breaker we can determine this from the fault analysis. From fault analysis we will be able to determine how much is the fault MVA or short circuit MVA. Then the circuit breaker we need to choose according to that short circuit MVA rating. So question number 62. The transmission line distance protection relay having the property of being inherently directional is. So four options are given: impedance relay, Maho relay, Ohm relay, and reactance relay. So impedance relay is same as Ohm relay. So basically impedance relay, Maho relay, and reactance relay. So out of these three, as we know, the Maho relay is the only relay which possesses the directional property. So if we see the characteristic of Maho relay, this is the characteristic. This is a circle which is passing through the origin. So if impedance falls within this circle, then this relay will trip. Outside this, relay is going to restrain. So if we interpose the directional characteristic, then directional characteristics will be something here. So here in this direction, relay is going to trip. Here, if fault take place in this region, the relay will restrain. Basically this is the impedance plane or X plane. So here as we can see, for this Maho relay, if fault occurs in this direction, relay is not operating. Meaning is that Maho relay possesses the directional property. What about reactance and impedance relay? So this is for Maho relay. So if you draw the characteristic for impedance relay, then it will look like this. So here also this characteristic is a circle, but its origin is at the center. The center of circle is at the origin here. So within this relay strip and outside, relay is going to restrain. So this is our resistance, this is the reactance. If I consider the directional property here, so this is the directional relay characteristic. So here relay is going to trip in this direction, relay is going to restrain. So in this particular region, so even though the fault is in the opposite direction, still this impedance relay is going to be operated. So therefore it does not possess the directional property. So same thing will happen for the reactance relay, whose characteristic we can draw like this. So here in this direction, relay is going to trip. JXR. So for all this part, relay is going to be tripped. So if we interpose the directional relay characteristic, here relay is going to trip in this direction, whereas in this direction relay should restrain. But here as we can see, from the characteristic of reactance relay, for all the part below this line, relay is going to trip. So for all this region, relay is going to trip, even though fault is in the opposite direction. So actually, if it possesses the directional property, then relay should not trip. But from the characteristic of reactance relay, it is tripping for this fault also. Means this relay also does not possess the directional property. So this one is for the reactance relay, and this is for impedance relay. So out of these three, only Moho relay is the only relay which possesses the directional property. That is the reason we use Moho relay for a long transmission line. Impedance relay is used for medium, and reactance relay is used for the short transmission. Now moving ahead, question number 63 asked in Mahatransco AE exam 2022. The per unit impedance is given by. Now this is the direct question. Now whenever base MVA and base voltage is changed, how we can determine the per unit impedance to the new base values? So the formula is Z per unit new is equal to Z per unit old, that is the original per unit value at old base values, into SB new divided by SB old into VB old by VB new whole square. So where SB is nothing but the base MVA and VB is nothing but base kV. Usually voltage it will be in kilo, and MVA, that is the apparent power, it will be in MV. So out of these 5 options, if you see, so this one is the correct. Z per unit new equal to Z per unit old into SB new by SB old into VB old by VB new whole square. So this kilo square it will be mega, and hence mega will get cancelled in case here. So correct answer it will be option A. Question number 64. The dielectric loss in the insulation of a lossy underground cable due to leakage current is. So 4 options are given. This question is asked in Engineering Services exam year 2018. Now we know that cable, it can be represented as a parallel combination of R and C. So this is the current taken by the cable. Current flowing through the resistance is IR. Current flowing through the capacitor is IC. This one is C. And this voltage, let us say this voltage is V. So we need to determine how much will be the dielectric power loss. So of course power loss will be taken place due to the resistance itself. So ideally what we want, we want underground cable to have only capacitor, but it will have a resistance also. So the power loss due to this resistance is nothing but the dielectric loss. So how we can determine the dielectric loss? For that we can draw the phasor diagram. So as it is a parallel combination, we can take voltage as a reference. So if I take V as a reference, then I will draw voltage along positive x-axis. Now we know that current and voltage are in phase for resistance. So current phasor will be along same line. This will be IR. Next IC. So for capacitance, current leads the voltage by 90 degree. So IC, this is IC, and IR plus IC is nothing but I. So if we apply KCL, I is equal to IR plus IC. So if we complete this, so this particular current resultant, it will be the resultant current combination of IR and IC, and this angle is the loss angle delta. So delta is the loss angle of cable. Now we need to determine the dielectric loss. So for pure capacitors, there will not be any power loss. So power loss will take place only due to resistance. So power loss P, we can write it will be power loss due to resistance itself. And as we know the voltage, so we can write it as V square by R. As they are in parallel, V, in terms of V we are writing. We can also write IR square into R, but as a usual practice for parallel combination, V is constant. Therefore, we take expression in terms of V, and in option also we have to write in terms of V. Now there is one term called as dissipation factor, that is tan delta. So we can write dissipation factor, that is tan delta, equal to, if you apply tan delta here, so that is the opposite side, which is this side, that is IR, divided by adjacent side, that is this side IC. So this is nothing but the dissipation factor. tan delta IR by IC. So by Ohm's law, IR is nothing but V by R and IC is nothing but V by XC. Ohms. Now this V and V will get cancelled here. So in numerator we will get 1 by R divided by 1 by X. So this XC will go in numerator, R will be in denominator. Now what is XC? XC is nothing but 1 upon omega C. So dissipation factor tan delta is nothing but 1 by omega C R. Now from this, what will be R? R will be equal to 1 upon omega C tan delta. Now we can put this value of R in this equation. We will get dielectric loss P equal to V square into, so 1 by R. So 1 by R if we write, it will be omega C tan delta, because it is 1 by R. So if you do 1 by R, it will be omega C tan delta. So dielectric loss is given by V square omega C tan delta. So correct answer it will be option C. Moving ahead, question number 65. The stability of a system when subjected to a disturbances is assessable by which of the following methods? Swing curve, equal area criteria, power angle diagram, power circle diagram. So which are correct? Now whenever we want to assess the stability of a system, there are various ways to assess that. So swing curve. So we can judge whether system is stable or not by using swing curve. So what is a swing curve? It is basically a graph of delta versus t. So how delta behaves with respect to time is nothing but the swing curve. So if let us say delta increases, initially delta will have some value. Suppose in case of some disturbance delta increases and after some time it stabilizes. Then we say that system is stable. But suppose after this point delta increases to a very high value. Then in that case your system will be unstable. So for steady state we say that delta should be less than 90 degree. For transient delta can be greater than 90, but it has to be stabilized. It should not go to a very high value. So that's why practically we keep the delta in between 30-40 degrees, so that even if fault or some disturbance take place, your delta may swing. It may go beyond 90 degree, but again it will come back to some normal position. So here in this case your system will be stable. So by studying the variation of delta with respect to time, we can judge whether our system is stable or not. So swing curve we can use. Equal area criteria, as already we have studied, in order to assess the transient stability, equal area criteria we can use, which is basically a graph between PE and delta. Okay, that already we have studied. Then power angle diagram can also be used to study whether the system is stable or not. So power angle diagram is nothing but a variation of P and delta. So if we consider the variation like this, because PE is P max sin delta, we already know this. So it will have a variation similar to sine function, sin delta. So this one is 180 degree, 90 degree, 0 degree, minus 90, minus 180. So this portion it will be a motor, in this portion it will be a generator. So we can judge the stability of system by using this diagram also. So this method is also applicable. Power circle diagram, so that is used to assess the transmission line performance to determine the compensator rating. So reactive power limit, the required reactive power compensation we can determine by using this. So it is not used to judge the stability. So correct answer will be 1, 2 and 3 only. So option D is correct. So question number 66, which is asked in recent Mahatransco exam for the executive engineers 2024. For a single circuit 3-phase line, the mutual GMD is equal to the equivalent equilateral spacing D1, D2, D3. Now we know that if equivalent equilateral spacing is there like this, RYB phases, and distance between them, let us say D1, D2, D3. So of course if it is a equilateral, all the distances will be same, but even if they are not equal, we can write D1, D2 and D3. So in this case, the mutual GMD we can determine as a cube root of D1, D2 and D3. Correct answer it will be option A. Now why we are calculating self and mutual GMD? Because we need to calculate the inductance and capacitance. So inductance is 2 into 10 raised to minus 7 natural log mutual GMD by self GMD, Henry per meter per phase, and capacitance C is 2 pi epsilon 0 upon natural log mutual GMD by self GMD. So in order to calculate these line parameters, we need to use concept of self GMD and mutual GMD. Here of course unit will be farad per meter per phase. Here it will be henries per meter per phase. Next question, question number 67. Match the items in list 1 type of transmission line with the items in list 2 type of distance relay preferred and select the correct answer using the codes given below, asked in GATE exam year 2009. So already we discussed, for short line we use reactance relay, for medium line we use impedance relay. Impedance has a unit of ohm, therefore ohm relay. So this is nothing but impedance relay. And for long line Mho relay, as it possesses the directional property. So A2, B1, C3. Correct answer will be option A. 68. Insulation resistance of cable is 10 mega ohm for 50 km length. Then insulation resistance for 5 km in mega ohm will be. So 5 options are given. Again asked in Mahatransco AE exam year 2022. Now remember the formula for insulation resistance, which is given by R equal to rho upon 2 pi L ln R by R. This is basically insulation resistance. So here R is the radius of cable considering the outer sheath, and R is the radius of conductor. Small r is the radius of conductor. So what we need to remember here, that insulation resistance is inversely proportional to the cable length. That we need to remember. And one more thing that we have observed, that capacitance of insulation cable is directly proportional to the cable length. These two expressions we should remember. Now here question is asked about insulation resistance. So we can write insulation resistance in second case divided by insulation resistance in first case. It will be, as they are reciprocal, L1 by L2. So insulation resistance in second case will be insulation resistance in first case, that is 10 mega ohm, into L1, the original length is 50 km, divided by L2, new length. So if we simplify this, so 5 10s are 50, 10 into 10, that is 100 mega. So if length is reduced, insulation resistance is going to be increased. So from 10 mega ohm, it will be increased to 100 mega. So correct answer will be option B. If the same question is asked some different values for capacitance, then relation is directly proportional. Question number 69. Condition for distortion-less transmission line is. So distortion-less transmission line means characteristic impedance ZC is purely resistive. Now what is the expression for ZC? It is under root Z by Y. It is equal to under root R plus J omega L divided by G plus J omega C. Now if ZC is purely resistive, its angle, it will be 0 degree. Now if we calculate angle of this, so this will be raised to 1 by 2, that is half. Now how to determine the angle? If a rectangular form is given, so tan inverse imaginary term omega L divided by R minus tan inverse angle of denominator, that is omega C by G, that is equal to 0. Because we know that for resistance there is no question of angle because it is a real term. So angle of ZC should be 0. This is nothing but this raised to 1 by 2. So 1 by 2 into angle of this tan inverse omega L by R minus tan inverse omega C by R. So if we simplify this, 1 by 2, 2 will go in this side, it will be 0. So tan inverse omega L by R equal to tan inverse omega C by R. So this tan inverse on both sides, therefore we can write simply omega L by R equal to omega C by R. So this omega will get cancelled. So what we are left with, L by R. Oh, some mistake is there, I think here. Omega C by G should be there, right? Yeah, C by G. Yes, so L by R will be equal to C by G. So if we simplify, RC should be equal to LG. That is the condition for distortionless line. So distortionless line means characteristic impedance is purely resistive. By this method, we can see that when RC is equal to LG, our line will be distortionless. Correct answer, it will be RC equal to LG. Question number 70. A transmission line of 80 km length is operating at 400 Hz. It can be classified as short, medium, long, all of above. Asked in Mahatransco Executive Engineer exam this year 2024. Now we remember that we can classify the line based on the product of LF. So we can classify the line based on the product of line length and frequency. So if product of L and F, if it is less than 4000 km Hertz, then we call that line is a short line. If this product L and F is greater than 4000 km Hertz, basically line length unit will be kilometer, frequency unit is Hertz, and if it is less than 12,500 km Hertz, then it will be medium, and if LF is greater than 12,500 km Hertz, the line will be classified as a long transmission line. So from where we have got this figure? So basically, if we assume frequency as 50 Hz and if line length is less than 80 km, then it will be a short. So if you multiply 80 into 50, it will be 4000. For medium, line length is greater than 80 km and less than 250 km, then it will be medium. So 250 into 50, that will be 12,500. And if line length is greater than 250 km, then it will be long. So 250 into 50, 12,500. The reason of choosing product of L into F as a selection criteria, because frequency might be given different. During normal case, power frequency is 50, but the question may be based on the communication line also. So where frequency can be anything. So therefore you remember these three relations. Now here, if you multiply 80 into 400, so line length into frequency 400, that will be 32,000 km Hertz. So clearly 32,000 greater than 12,500. Therefore this line will be categorized as a long transmission line. So we should not take the decision solely based on the line length. We should also have a close look on the frequency. If frequency is 50 Hz, then same line we can consider it as a short. Okay, because it is 4000 km Hertz. Okay, less than or equal to we can consider. So it will be a short line. But here, as frequency is 400 Hz, therefore it will be a long line. Thank you.